Hi, I am Pradosh, faculty from the Department of Biomedical Engineering, Sri Shanmugha College of Engineering Technology. In this session, I am going to discuss about the architecture of industrial automation system. First, we will see about the relationship of automation system. So in this graph, we can see there are three types of automation explained. First one is a fixed automation. Fixed automation, we can see from the graph that the number of production volume produced will be more. Since automation fixed, the same thing has to be repeatedly reproduced, so we can get the more number of production volume. But the number of different parts, that is a product variety will not be possible with the fixed automation. So the next case is the flexible automation system, where we can find different types of products being possible with the flexible automation system, and the production volume will be medium in that case. Next one, the third case is the programmable automation system. In this case, the number of different parts produced will be more, but the production volume will be lesser. Since it is programming different types of parts, it can able to produce only the less number of volume. So this is the relationship about the automation system. Next, basic elements of an automated system. First, power needed to complete any particular task, which need to drive both controller and process. The main function is to convert the current from source to correct voltage, current and frequency as per load requirements. Next is program of instructions. It is nothing but a set of instructions given to the computer to accomplish the automated action. That is nothing but the program only, we are calling it as program of instructions. Next one is a control system. Control system is used to perform the program of instructions, the process to take out successful manufacturing operation. So there are two types of control system available. One is open loop control system and the another one is the closed loop control system. Open loop control system means the output will not be bothered in that case. So whatever is the output that will be coming from the system, we are not bothering about that output. So that is a open loop control system. So no feedback will be used in that case. The another one is the closed loop control system. Here we will be using the feedback in order to monitor the output, and based on the set point we will tune the system to achieve our process variable as the set point. So this is nothing but the closed loop control system. So usually if we see the control system majorly in automation system, we'll be using the closed loop control system. Requirement of automation systems. The device must be able to handle multiple tasks as quickly as possible. There should not be any human intervention. The operation performed should be error-free. Productivity should be increased. These are the requirements of automation systems. Next is the architecture of industrial automation systems. So this is the architecture figure of the industrial automation system. You can see different layers here. The bottommost is the processor machines. Next is sensors and actuators, which is considered to be the level 0. And the level 1 is the automatic control. The level 2 is the supervisory control. Level 3 is the production control. Level 4 is the enterprise. So the level 0 and 1 comes under the industrial automation, and above that we are considering to be a industrial IT. So this is the architecture diagram of the industrial automation systems. Architecture of industrial automation system, in which the level 0 is a sensor and actuator that directly interact with the process of the machine. Level 1 is an automatic control and level 2 is a supervisory control. And the level 3 is production control, responsible for maintenance, production quality, inventory. Level 4 enterprise is mainly concerned with management functions, sales, marketing, etc. First, we will see about the level 0, which is nothing but sensing and actuation. Industrial sensor system includes two major elements, the sensing element and the actuator. The sensing element in its simple form is actually a signal conditioning and processing. Generally, a signal conditioning and processing composes the following items: analog electronic signal conditioning followed by digital processing, diagnostics, calibration, configuration, communication, signal protection and transmission. Architecture, the second element of the industrial sensor system is the actuator. That is, we have said that in level 0, sensor and actuator. First we have seen about the sensor, next we are going to see about the actuator. Actuator takes the logic information from the controller and convert it to a physical plant input. The logic is no longer powerful, so it requires doing a lot of power amplification. The actuator does two main functions. One function is the variable conversion, and the second function is a big amount of power amplification. An actuator has its own sensor, it has a controller and sometimes an analog signal processing and some power amplification. For hydraulic case, we can say can handle a lot of power in small volume. The control valve is to be open or closed, so it requires something to move. The hydraulic is used to move the stem. This is about the one example of an hydraulic actuator. Next is the level 1, which is an automatic control. The set point may change due to disturbance. So the automatic control loop maintains a set point. Automatic control can be two types: continuous variable control and the discrete control. The continuous variable control includes the following: continuous analog, continuous process variable, closed loop control, track hold set point. Set point is not constant, it should hold it. Reject disturbance, generic PID special for tunable, dedicated digital RTS, comparatively inexpensive. The second type of automatic control is the sequencer discrete event control. That is to control of discrete variable process on or off or high, medium, low. That is a discrete control. Next is level is the supervisory control. The automatic control maintains a set of temperature. For example, it does not know what temperature to maintain, but the supervisory control gives commands and set point. There is something which is very important. It's not necessary to use the same controller that may use when time plant startup or plant shutdown. That is, here we can use different controllers, two different controllers, one for on and another for off. That is for startup and shutdown. We want to start up, one controller can take care of that and the another control will take care of the shutdown process. If we use normal operation, we can use another control also. So if we give a command on which control to use, based on the process of input output, the supervisor does lot of calculation whether the system is working nicely or not. If it finds some problem, it will gives various signals to ensure which control you use and when. The supervisory control manages a number of controllers. The supervisory control does the following jobs: that is set point computation, startup, shutdown, emergency operation, control reconfiguration and tuning, performance monitoring and diagnostics, operator interface, domain dependent, hard, soft, real-time, expensive. These are the jobs that can be taken care by the supervisory control. Level 3 is the production control, which take care of process scheduling, material handling, maintenance management, inventory management, quality management, resource optimization technology, online, non-real-time process. Production control is not a powerful machine. It takes abstract view of a factory how many pieces of equipment have been produced per hour, whether functional or not functional. Thus, here the software is generally offline. It is not concerned with the machine itself. Next level is the fourth level. It is similar to the third level. At this level, we are not so much close to the hardware. Look at the process. If it is abstract identity, we take the decision about them, analyze their performance, and also monitor them. In that sense, the layers up to from some other parts of the supervisory control as well as production control and enterprise control could be turned as tuned as industrial information technology rather than industrial automation technology, because automation has a kind of hardware and software flavor. On this case, it is information technology, full of technology. We are taking care optimization technology, but they are not concerned about hardware. It is not a real-time technology. Thank you for listening to this session. Thank you.